double angle formula, right? So the identities are going to become very important in this section and the next section. Crazy important. So let me give you a couple to try. I'll put them up on the board in case you don't have your book with you. I'll give you a couple to try out of the homework section. So page 465. Start you off nice here. Oh, okay. And then I'll take a turn for the evil. Let's see. Let's do one with. Oh, let's try tangent secant. Test it this time. Try to keep it down. No. If you put a cosine here, then u is going to be sine, and that derivative is just straight up.
Okay.
In fact, that negative, I didn't even put it there until I got to the next step. Where then I see, oh, I need a negative, so go back and right. So you don't have to know beforehand. You don't have to know beforehand. Just have an idea. I want to make u this. Oh, but the negative. Okay, I can put a negative in there. Yep. All right, so let me look real quick at number 2. The first thing I notice when I look at that is who's got an extra piece? Cosine, because the identities are related to squares, so even powers. Cosine's got an extra piece. I don't personally memorize when this is even, odd, whatever. So I definitely want to check off a cosine, right? And the sine, let me write it like this here. Well, that's sine. Sorry, sine's fine. Because now I want to let sine u be what? What do I want u to be? Yeah, I want u to be sine, so I want to rewrite the cosine piece, right? So if I have integral sine 6x, this will be 1 minus sine squared, and this piece here.
du.
Good. So now if I let u equal sine, du is cosine, so I get u6, 1 minus u squared, du. So let me just remind myself u is sine, u is cosine. And then I get u6, so u7 over 7 minus u8, so u9 over 9. I integrated too, sorry. You get u8.
Oh, because you multiply.
Yep, you distribute. And u was sine, so you get 7 sines, 9 sines. Bam. Okay, cool. How's that?
You have to use x instead of.
Oh, x, sorry. We were using theta earlier, you got all around. Now number 6. Number 6 is making the point that this book has no problems putting several procedures together at once. I mean, what do you do first here? I mean, what part of that has nothing to do with what we learned in this section? This section is all about sines times cosines or secants times tangents. It has nothing about square root of x's in there, right? So I got to first I got to first
Substitute.
deal with this, right? And I notice there's a square root of x in there also. And of course, this section doesn't say anything about sine of square root of x. So what do I have to do? What do I use?
Substitute radical x by u.
Yeah, so I use u sub. U is square root of x. Du. All right, this is not working as well as it. Du would be
1 over 2 radical.
beautiful. So all I'm missing here is a 2. So it's twice the integral of sine cubed u du. How are we doing so far? So I've only got one trig function in there, really. I got 3 of them, but so I shuck off a sine, which means what am I going to want to let u equal? So I can pull a sine off, right? There's an extra sine. So if I have sine u du, u would be what to lead me to that? Cosine. So I want to write this in terms of cosine. I mean, that's the process I use to get me where I want to go. I hate thinking, well, that one is even and that one's odd, so therefore I know. That doesn't tie it together with why it works. It's better to tie it together with why it works. So I can write this as 1 minus cosine squared sine u du, and then let me see u equal cosine. Oops, I'm gonna let
Z.
I use m, whatever you want to use. M is cosine. So dm would be
Minus sine.
negative sine, cool, right? So you have just multiple substitution steps. So I need a negative in there. So somebody had a good point earlier. I don't have to know that ahead of time. I just, when I do my u and my du, I just see what is it. Am I missing a 2? Am I missing a negative? And then I just make it balance out. So now I get negative 2 integral 1 minus m squared times dm. And that's damn nice. There's no foiling. There's no distribution even. It's just going to be negative 2 m plus 2
over 3.
m cubed over 3. And now, of course, you got to step back twice. M was cosine u, and u was
D for x. Square root of x.
square root of x. Cool. So right here, I just kind of put this as, so I really have to take one step back, right? U is square root of x. So now I can rewrite this as negative 2 cosine square root of x plus 2 cosine cubed square root of x over 3 plus c. Gruesome. Obviously, we all knew that from the beginning. Yeah, right. Yeah.
Can you put that negative in there from the derivative of
Yeah,
m?
from here.
Did it cancel out anywhere, or did you just?
No, I had to put it so that this piece could be dm.
Okay.
So that negative got sucked into dm. So this negative is still there.
Oh, okay. I see.
I had to put a negative there so this piece could become
Yeah.
dm. The balancer is still there.
Okay.
Yeah. And again, the stronger you are with the integral stuff you did in Calc 1, the easier this stuff is going to be, of course, right? And your derivatives. I mean, if it's been a while since you took calculus, you desperately have to go back and remember your derivatives. They should be right there on the tip of your tongue, or have a little table sitting next to you at the very least, so you can refer to that. Can't have that on a test, though, so. All right, have you guys made it to number 8 yet? Go ahead and if you haven't done number 8 yet, try it out.
Were you using M instead of V or U? M.
I was using m instead of u.
Of U. Oh, okay.
Because you've done that before, right? I mean, where you had to do several
Wow.
substitutions. So you always start with u, and then personally, I just go to m because that's not why, but I don't know why I do that. But I don't like to use v because then I start to mix it up with by parts. So m or something else. Yeah.
Okay, you don't want to use X and Y.
Yeah, I don't want to use x or y because then you might think you're fine at the end. Yeah.